All right, I finally have the software working. This took all day, super annoying. It turns out having one test running where you're only doing one command at a time, really easy. If you have two tests running completely independent from each other, the driver that comes with the Lambda Gen doesn't actually enforce the communication there, and you can actually have collisions if two packets are sent at the same time. Kind of silly, but anyway, I've rewritten their driver in LabVIEW here to both, one, it's now blocking when it's actually communicating with the instrument. I can't believe it doesn't do that already. And two, if there are any checksum errors right now, the driver just bails and it just says, we're hosed, done. And so now I've added a retest. So if you get a checksum error, which can occur, and I found actually that the checksum error can really occur when you're switching these FETs off. Of course, you have this inductive coil here, and then you're opening this FET, and even though the FET has a flyback body diode on it, you get EMI, you get radiated noise, and presumably it's corrupting the RS-485 data stream, which is how these four supplies are talking to each other. So anyway, we have data errors, but we have fixed that now with retest and also some strategic delays whenever we're turning these two FETs off. Turning them on doesn't really matter because the current ramps up slowly. It's when you turn them off that we were getting data corruption. So anyway, we were having issues where the system would always fail in the exact same spot. And so I was like, oh, okay, this is obviously a software issue, but it's not. It was a radiated noise issue. So anyway, test setup is better now. I've rewritten this. I'll probably resubmit Lambda Gen's code to the LabVIEW instrument driver network. Anyway, here, let's look at the temperature of these cells. So we've been running this test for a while now, and you can see that the cell is relatively cool. It might look really red there, but it's only a 10-degree difference in temperature from ambient, maybe 11. So we're charging this at 10C and discharging it at like 18 or 19C, and it's only rising 10 degrees Celsius. So that's really, really impressive. And of course our other test head is sitting there working, just doing its thing over there. Anyway, this will probably be my last video on the actual test setup. It does appear to be working very well now. And you can see here that we are doing our charge and discharges extremely rapidly. Our last charge was 216 seconds, which is like 3.5 minutes. And our charge is, maybe closer to 5 minutes or whatever. That's a very quick charge and discharge cycle. So we'll see how quickly it trashes these EHW5 modules. Anyway, as always, thank you for watching. This is just going to be running now for a couple months probably. So hopefully now the updates will be slower and I can just start on the firmware tomorrow, because this was my last big task before that.